Hi everybody, Ms. Lee here. Today we're going to be talking about simplifying complex fractions. So I'm going to do an example for you where we simplify one together. Okay, so obviously you see that this is one big fraction because we've got the one big division sign right here. And basically you have fractions within fractions. So you have a fraction here, you have a fraction here, you have a fraction here. Ultimately, this is why it's called a complex fraction, because you have like fractions of fractions of fractions. And so what you want to do is turn it into one compact fraction, and you can have like x does not equal after and define it in that way. So you basically want to simplify it so it becomes a polynomial over a polynomial. So yeah, let's go ahead and get started then. What you want to do first is factor everything. So in general, first step for a lot of these types of problems is start by factoring. So factor everything. I don't see a huge amount of things to factor, but I have some key ones. So there's this one, the ones that have like the square. So 3 minus 3x squared. So 3 minus 3x squared, you'll recognize that as if you switch them around as negative 3x squared plus 3. So we'll go ahead and factor out a greatest common factor there, which is going to be a negative 3. So you factor out the negative 3. And then you have x squared minus 1, and you'll recognize that to be a difference of squares, And so this factors to negative 3 times x plus 1 times x minus 1. Okay, so that's that factored. The other thing that I see that we need to factor is the denominator in the fraction that's in the denominator. So that x squared minus 3x minus 4. This looks like it needs to be factored, so we'll go ahead and factor that. That one's easy. So x squared minus 3x minus 4. We typically make our big x. We put negative 4 at the top and negative 3 at the bottom, and we end up with negative 4 and 1. And so this should factor to x minus 4 times x plus 1. So we'll rewrite the entire fraction with this and this incorporated. So we have 1 over, and then negative 3 times x plus 1 times x minus 1. Divided by, and then you have 5 over x plus 1 minus x plus 4 divided by x minus 4 times x plus 1. So when you see something like this, what you want to do is go ahead and add so that you have one fraction in the numerator and one fraction in the denominator. So you see that the culprit is right here. The denominator, you have two fractions being subtracted from each other. And so you've learned how to subtract fractions before, subtract rational functions before, and so we'll go ahead and subtract that. Your basic generalization of this step would be to make sure that there is one fraction in the numerator and one fraction in the denominator. Okay, so for the denominator, we're going to go ahead and subtract these from each other. So you'll see that the least common denominator would be x minus 4 times x plus 1, because you see an x plus 1 over here and an x plus 1 over here. So we'll go ahead and multiply the first one by x minus 4 over x minus 4. And as you know, when you multiply by the same thing over the same thing, it does not affect the problem. So this does not change the problem. Minus x plus 4 divided by x minus 4 times x. Okay, and so we distribute that 5. And we get 5x minus 20 minus, and then we're going to distribute that minus sign as well to the x plus 4. So minus x minus 4. So in general, when you're subtracting, it's good to just distribute across. And then in the denominator, we have x minus 4 times x plus 1. So I'm going to just simplify that numerator, and then I'm going to rewrite the entire problem. So 5x minus x, that's 4x. Negative 20 minus 4, that's negative 24. And then we have that divided by x minus 4 times x plus 1. And again, this is just the denominator, so we're going to go ahead and rewrite the entire problem with the numerator and the denominator. So the entire problem is 1 over negative 3 times x plus 1 times x minus 1 divided by, and then what we got here because this was the denominator. So we have 4x minus 24 divided by x minus 4 times x plus 1. So we have successfully condensed the numerator into one fraction and the denominator into one fraction. So if you remember the definition of fractions or how fractions are defined, it's basically top divided by bottom. So we're going to rewrite this as a division problem. So you should know that, for example, if you have like 5 halves, that's basically 5 divided by 2, right? So that's the same thing here. We're going to do this divided by this. And as you probably remember from our multiplying and dividing from before, when you're dividing, that's the same as multiplying by the reciprocal. So multiplying by the reciprocal. So we have 1 over negative 3 times x plus 1 times x minus 1 times, and then we're going to flip this because that's how you find a reciprocal. So we have x minus 4 times x plus 1. So we have x minus 4 times x plus 1 divided by 4x minus 24. So I'm just going to go ahead and factor out a greatest common factor from that. So that's 4. So we have 4 times x minus 6. So again, we're multiplying by the reciprocal. And so now this is just a regular division of rational expressions problem. So you just need to look for factors in the numerator that can divide out with factors in the denominator. And you'll notice that there is an x plus 1 and an x plus 1 in the numerator and the denominator. And when you one anything out, so when you divide anything out, you always want to remember to write x does not equal something at the end. So because we got rid of this, but x plus 1 was in the denominator, you know your answer has to include x does not equal negative 1. Okay, and so we'll just multiply straight across. You can leave it factored as your answer. So you have x minus 4 in the numerator. And in the denominator, you have 4 times negative 3, that's negative 12, times x minus 1 times x minus 6. And that's how you simplify a complex fraction. Go ahead and try some practice problems on your own, and happy day!